Ever pondered the nature of light? Is it merely a source of brightness or something more profound? Light, a fascinating phenomenon, has intrigued scientists for centuries. It's not just a force that illuminates our world, but a form of electromagnetic radiation exhibiting a dual personality. On one hand, it behaves like a wave, spreading out and overlapping with other waves. On the other, it presents itself as a particle, a photon that can be counted and measured. Imagine a sprinter that never tires, never slows down. That's light for you. It sprints through the universe at an unimaginable speed of approximately 300,000 kilometers per second when in a vacuum. This speed is so fundamental, so constant, that it forms the bedrock of Einstein's theory of relativity. It's like the universe's heartbeat, unchanging and relentless, a cosmic metronome, if you will. But here's an intriguing thought. Can this sprinter ever be stopped? Can light, known for its unyielding constancy, ever be halted in its tracks? It seems counterintuitive, doesn't it? After all, the very idea of stopping implies resistance, a force working against motion. But light, by its very nature, is designed to overcome resistance. It's like trying to stop the wind with a net or halt a river with a sieve. Yet scientists, those intrepid explorers of the unknown, have dared to ask this question. They've peered into the heart of light, delved into its nature and sought to uncover its secrets. In the process, they've stumbled upon a startling discovery. Under very specific conditions, light can indeed be stopped. It's as if the cosmic metronome, the relentless sprinter, can take a breather. Intriguing, isn't it, the concept of stopping something that's always in a perpetual state of motion? The enigma of light continues to unfold, challenging our understanding of the universe and forcing us to rethink the nature of reality itself. As we journey further into this exploration, we invite you to join us in this quest for knowledge, to peer into the heart of light and discover the marvels that lie within. Now let's dive into the realm of scientific marvels where physicists manage to halt light. Picture this, a laboratory humming with the energy of anticipation. It's here at the University of Darmstadt in Germany that a team of scientists embarked on an audacious experiment to stop light in its tracks. So how did they do it? They started with a special crystal. But this was no ordinary crystal. It was doped with praseodymium ions, a rare earth element. This unique combination created a medium with optical properties that could be manipulated. Now imagine a beam of light zipping along at its usual breakneck speed. What these scientists did next was akin to throwing a speed bump in front of a racing car. They shone a control laser beam into the crystal. This action, like flicking a switch, altered the crystal's optical properties. But here's where it gets even more fascinating. A second beam of light was then passed through the crystal. This second beam, due to the altered optical properties of the medium, began to slow down. It was like watching a sprinter suddenly start to wade through treacle. And then came the real showstopper. The control beam was switched off, and what happened to our second beam of light? It was effectively frozen in place. Just like that, the fastest thing in the universe was brought to a standstill. The whole process took about a minute. 60 seconds to alter a fundamental property of the universe. It may not sound like much, but in the world of physics, it was a moment that made the Earth shake. But remember, this isn't something that happens just anywhere. It took a very specific set of conditions to achieve this mind-bending feat. So, under very specific conditions, light can indeed be stopped. A thought-provoking revelation, wouldn't you agree? Let's take our curiosity a step further and venture into a hypothetical world where light can be stopped naturally. In this parallel universe, the very fabric of our existence would undergo a dramatic shift. Begin with the simplest change, the cycle of day and night. If light could be paused at will, we could control the duration of daylight. Imagine regions with perpetual daylight or constant darkness, reshaping ecosystems and altering the rhythm of human life. The rooster might crow at noon, and the owl might hoot at the break of dawn. Now, consider the revolution in communication. Light, the fastest courier known to us, could be stopped mid-flight, holding messages in its bosom. Think of it as a game of freeze tag on a cosmic scale. This could pave the way for advancements in data storage and transmission. Information might be held in beams of light, stored indefinitely and released when needed. It's an entirely new way to think about sending and receiving data. Artists, too, would find a new playmate in stopped light. They could shape beams of light into dynamic sculptures, create environments where light and shadow dance in ways previously unimagined. It would be like painting with light, only the paintbrush is a beam of photons frozen in mid-air. And let's not forget energy systems. The potential to store light indefinitely could transform how we generate, store, and use energy. Light-based batteries could provide power without degradation, a beacon of clean, renewable energy. This hypothetical scenario paints a fascinating picture of how our world could transform if we could control light's movement. From the rhythm of our days to the way we communicate, create art, and power our world, the ability to stop light could usher in a new era of human civilization. It's a world that lies just beyond the edge of our imagination and understanding, reminding us that there's always more to discover in the interplay of light and darkness. But stopping light isn't just a scientific curiosity, it opens a Pandora's box of philosophical questions. In the realm of philosophy, the ability to stop light could be seen as tampering with the very fabric of reality. Light, a universal constant, a symbol of constancy and speed now arrested. If such a fundamental aspect of our universe can be manipulated, what does that say about the nature of reality itself? Is reality as immutable as we once thought, or is it more malleable, subject to the whims of scientific discovery? And then there's time. For as long as we've understood it, the speed of light has been a linchpin in our understanding of time. It's the cosmic speed limit, the rate at which cause and effect propagate through the universe. But if light can be stopped, what does that mean for time? Does it continue to flow unhindered, or does it too grind to a halt, frozen in a tableau of stopped light? This may seem like esoteric musing, but it has tangible implications. If we can control light to the extent of stopping it, then we have the power to alter our perception of reality and time. It's akin to possessing the remote control to the universe, with the ability to pause, play, and rewind at will. This is not just about the physical world, but also about our understanding of it. It forces us to rethink our definitions, our models, and our theories. It challenges our understanding of the universe and our place within it. Are we mere passengers on this cosmic journey, or do we have a hand on the steering wheel? So, what have we learned from this exploration? Well, we've uncovered the dual nature of light, behaving as both a wave and a particle. We've marveled at its supreme speed, the fastest in our universe, a cornerstone of Einstein's theory of relativity. We've witnessed how, under specific conditions, light can be stopped, challenging our fundamental understanding of this radiant phenomenon. In a parallel universe where light stops naturally, we've speculated on the profound implications, from redefining day and night to revolutionizing communication, creating new forms of art and transforming energy systems. We've pondered the philosophical implications, questioning the nature of reality and time. This journey into the realm of light and darkness serves as a reminder of the boundless potential of science to challenge and expand our understanding of reality.